Hello, everybody. My name is Etienne. We are here to talk about ARCore, some basics and tools. Who here has actually played with ARCore before, just for fun? All right. Not too many people, which is a good thing, because this is basics. Hopefully, some of you that have played with it will learn a thing or two, but you've been warned. All right. So I want to say thank you to my employer, Shopify. It's thanks to them, in part, that I'm here today. So they cover expenses, and they encourage us to go and speak for our personal development. So they're really nice company. I encourage you to check them out if you're curious, mostly based in Canada. Also, I want to thank the Google Developer Expert Network. So I'm part of that network, and they also help us to go out and speak and give us information. So they're very supportive. So that's, I think they deserve a well-deserved thank you to them as well. All right, so that was the part of the talk where I need to breathe a little bit, calm down the stress. You're a nice crowd, so I think I'm going to be good. All right, so the goal of this presentation is to basically show you the basics, right? So I find that for a library like ARCore, it's fun to work on concrete use cases. So since my employer is called Shopify, you might guess that we're into e-commerce. So if you're not aware, we're a software as a service platform. So it allows big and small merchants to sell online and in person. So given that, my theme today is going to be the pop-up shop. So you might be wondering, what is a pop-up shop? It's like a bit of a trendy thing right now. The idea is that you as a merchant are going to go out, set up a temporary stall somewhere and sell your products and try to see if there's a good product market fit, maybe discover new people that you could sell to, build a new market. So here we see a picture of a San Francisco library that went to Tokyo to actually sell some stuff. As you can see, they have really nice little stalls, and as you could guess, these things are not necessarily simple to set up, right? It's like a significant outlay of effort and energy. So since we're talking about virtual stuff, I thought, hey, ARCore might be a good fit to try to sort of basically build a small virtual pop-up shop, right? So I've sold you all on the idea, right? We're ready. Right, we're going to build ourselves an Android mini collectible pop-up shop. And here we go. All right, so we dive right in. So if you've looked at the camera emulator app, the camera in the emulator lately, you've noticed this virtual room that you can walk around into. So you're probably aware of this. You might not be aware that you can move around in this space using the Alt, the WASD keys, and your mouse. So that's interesting if you're doing AR, because you can also use ARCore with this and detect surfaces. So it allows you to develop on your emulator without necessarily having a physical device next to you. Something that you might also not be aware of, in the emulator, you get pre-programmed macros to run around in this space. So those are also very useful when we start developing our app. Right. So at a very high level, what does an ARCore app look like? Like this. You have an activity. You have your own activity, custom activity, obviously, depending from the big one. You have a simple layout. And more importantly, you have an AR fragment somewhere in there. So there's nothing really special. We start a really simple app. If you've played around with OpenGL stuff before, you might remember that there used to be some complex activities that you would extend from, and nothing like that here. The only thing we're responsible for right here is to detect whether or not we're running on the right version of OpenGL for ARCore to be supported. It's actually kind of odd because you'll see that everything else is done for us, but that's our responsibility, so we take care of that. We check that OpenGL 3.1 or 3.0 is actually on the device and that we're good to go. So what next? Well, thanks to the Sceneform library, all we need to do is to get the ARCore started is to set up the AR fragment. So we add it to our activity main.xml. Pretty vanilla stuff so far. We do give it an ID because to manipulate ARCore and to interact with the system, we do need to have that AR fragment on hand. So right now we're going to look up that fragment right away, hook it into our activity, and we're done. Right. So you can see on the UML diagram, the basics are covered. What do we get for so little work, right? You might be like, oh, what's going to happen? What's so special about this? We actually get quite a lot of stuff. So the nice big bonus is that AR fragment's going to take care of all the permissions for us. They're going to ask for permissions on our behalf. We don't need to figure out anything about return values and any of that. You can even add your own permissions to the list if you have a special app that requires other services on the device, so that's nice. the next thing that ARCore is going to take care of for us is to make sure that the library on board is the correct version. So, much like Play services, ARCore is a library that you get online and that is updated through the network. The thing is, if you're on the emulator, that doesn't work, right? So, what do? Well, you just need to download the emulator-specific version of this at this address and install it on your device. So once that's done, we're ready to actually start developing. Right, so when you first launch your ARCore application, the one I just showed you with basically nothing except the AR frame, you're going to be greeted with this little animation. So that's telling the user, hey, you should be moving around so we can detect surfaces to start playing around with. So you can actually interact with that and turn it off or even change it for your own custom animations. All right, so I'm going to use the macro feedback, the macro feature I was talking about earlier. So we're going to be walking around, pressing play and having the right thing selected. It goes through a pre-programmed script. As you can see, it actually also triggered the detection of surfaces, so that's a nice plus. You could imagine some testing in there if you wanted to, like always having the same path pre-programmed. All right, so we're in our little room in the virtual apartment. So at this point, ARCore detected a plane, and as you can probably see, yeah, it's not so bad. You can see the little white dots on the table surface, so that's indicating, hey, I found a plane. We can start interacting with this thing. Right. So if we now look at the wall, what you can also see is that the wall surface is being detected. So if you played with ARCore when it came out, this was not actually an available feature, so that's a nice new little bonus they put in probably around a year ago, maybe a little bit more. All right. So you have three types of plane in ARCore, nothing super special. You have the downward-facing horizontal, upward-facing horizontal, and the vertical, like I just showed you. So once the plane is detected, ARCore keeps track of it, so that's kind of important. Plane is a type of trackable. So we're going to be looking at a few UML diagrams today. Like I want to warn you, ARCore as a library is very object-oriented, and it's sort of important to keep track of what is what, which is not a pun on trackables. But anyway, so trackables. What kind of trackables do you have? You have points, which we're not really going to talk about today. Augmented faces are a new feature, kind of interesting. You can detect your own face and start playing around with that. Today's also out of topic, so we're not going to talk about that. We're mostly going to focus on planes and augmented images. So trackable basically has a few states of its own. What you can do with a trackable is create something called an anchor. Anchors are going to be useful when you want to hook up objects to your scene. And both trackables and anchors share the tracking state. So it's worth spending a little second on that. When a trackable is tracking, that means, as you would guess, that you know where the object is in space or the feature is in space, and that the position of that anchor is going to be updated in real time. If we hit pause, that signifies that the system's sort of not too sure what's going on, you've moved too fast, that the light is not right. So at that point, the updates for the positions are going to stop. So you can't really trust those numbers at that point as well. And the last state is stopped. When you're stopped, the trackable is gone, it's never going to come back, it's dead. If you have anchors that are themselves have nodes attached to that, we'll see what nodes are in a second, they will also be disabled in your scene. Right. So, our next goal is to add the plain old vanilla Andy the Android figurine on the plane that we detected on top of this table earlier. So when the user taps on the screen, we want Andy to pop up there. So what we're doing when we're hitting the screen is that we are tracing basically a ray between the surface of the screen, our perspective, right up until the plane is found. And then we can register a listener, and that's going to tell us basically, okay, we found a hit on this segment in 3D space, and everything is taken care of for us. Right. So before we actually put that model up on screen, we need the model itself. So we're going to spend a little minute explaining what are models for those that are kind of new to this stuff. The Andy model is a very simple one. So it's something that you're going to find in all the sample apps that Google provides for you. The specific model is split in three different parts. So there's an OBJ file. OBJs are like an open standard dating back to the 90s. So it lists all the geometric data for your model. So you're going to have vertices, texture coordinates, normals, you name it. But it's very basic, as you can see. Human readable, pretty much. Numbers are in there. Usually big files, not very compressed, as you can see. The important part, or the interesting part basically, is that it also points to a material. So there's a material file that's referred to in this file, and you can see it here. So we're going to take a look at that one as well. Very, very short, that one. MTL here stands for Material Template Library. That's also part of the OBJ standard. So that describes how to shade and texture the 3D model that we saw defined in the OBJ file. You can see that it also points to a PNG file. So that one's our texture, right? So you can sort of recognize where that's going to go in your shape. So that's how we paint Andy with this specific model. So OBJ is one format that Sceneform supports. It's really old, as I mentioned. The good news is that we have support for GLTF in there as well. So GLTF is a very modern format. It stands for GL Transmission Format. It allows you to do something called physically based rendering to your models. So that's a technique that allows you to create ultra-realistic models. It sort of mimics it sort of stores the physical property of your object, and then it can do pretty nice simulations on how the light bounces around. So you can say stuff like, my surface is plasticky or metal-y, it's rough or not rough, and depending on those parameters and how you prepare the model, you can do really, really realistic things with it. All right, but right now we're going to continue with our simple Andy model. We're not going to delve into GLTF too much. All right, so we have our 3D model. What do we do now? We need to get that thing into the Android resource system. So that's when the Sceneform Gradle plugin comes into play. Once you've applied the plugin to your Gradle file, you can start declaring Sceneform assets into it. So in the case of our Andy, we point to the OBJ file. The second option that you can see there, we leave to default. That one specifies where to find custom materials. We're not going to use that right now. After that, we specify where we want the Sceneform asset definition file to end up. So that's this SFA file you see on the third line. So that's a Sceneform specific file format. And we have at the very end the SFB file where we want that to end up. And that's the actual asset that's going to be loaded by your app. It's a binary format of the SFA file, basically. So the interesting part about the SFA file is that it's actually human readable. And in some cases, you're going to want to go in there and edit it, right? So that's one thing to remember. The format used here is something they specifically call JSON-ish. So somewhat obvious. I think the ish is the part where you put commas at the end of everything, even though you're done with your declaration. You use that to generate the SFB file, as I mentioned, which is typically what you load in the Sceneform library. So by double-clicking on an SFB file in Android Studio, you can visualize the model in the Sceneform preview tool. So when everything is done right and it's building right, you can sort of get a nice little preview of what's going on with your model. Okay. Right, at this point we're going to talk about renderables. So renderables are the base class for models in Sceneform. We have two types of renderable. We have the model renderable and the view renderable. Right now our focus is going to be on model renderables. Those are the ones that are built from the SFB file I've been mentioning. So since creating one of those objects is a potentially expensive operation, creating the renderables is an asynchronous process. So the builders Sceneform provides, they will return to you a completable future. So in Google's sample Java code, this is what loading your resource looks like. There's nothing wrong per se here. I am not personally a fan of completable futures, and to be honest, it's because I haven't used them all that much. I'm more of a, wait for it, Rx Java person. Yay. So. If you know me, you know I was just looking for an excuse to put Rx Java in this project, but don't worry too much. You know, this is ARCore basics and tools. If you're not into Rx Java, I don't intend to sort of spam you too much with it. It's just one tool in the toolbox if you choose to so use it. Completable futures are fine. You could be using coroutines. Those are also really neat, right? So whatever floats your boat, go for it. So keeping the Rx shenanigans to a minimum, I will do one little thing. For starters, a small extension format. Wait, I'm skipping a little bit ahead. So I have this small extension function that's going to turn any future of type T, any, into an Rx Java single. So that's how I basically jump the two worlds, bridge the two worlds. So once I have this, I can get to this one. So this is how I turn the builders into a single in Rx Java. So if you're not too familiar with RxJava, basically all this allows you to do is to have a one-liner that will load the resource, and when it's done, it's going to call your callback. Fairly straightforward, even if you're not familiar with RxJava. Right, so how do we use this? Back in our activity, we can start loading the model. So like I was saying, this is one-liner. We don't have the subscribe call yet. That's basically what we're going to be using. Once we're done loading the model, what will we do with it? So again, our goal is to add Andy to the table. So when the user taps on the 3D plane, we're going to be getting some information back. Let's see. Right. So this is the code that allows you to put the figure down onto the table. There's a lot of moving pieces here, so we're going to break it down in little details. First off, the tap listener we've set here, that one is belonging to the base AR fragment, right? So you can see that right about here. That's where you assign it. So that gets called whenever a plane in ARCore gets tapped. So you're going to get the callback, you're going to know about it. Boom. And yeah. So how do we build that listener interface, right? What do we put in there? So first off, we need the renderable we just loaded asynchronously, if you remember, right? Then once we have that, we can start focusing on the listener itself. So the idea with the code right here is that you will only register your listener once you have the resource on hand. So it allows you to avoid this whole null checking nonsense, right? Which is my main beef with some of the code I've seen out there. So you only register listener when you actually have resources on hand. That gets to be really useful when you start having, say, 5 or 6 different models as well. Cool. So hit result. How does that work? When you have a hit result right up there, you're going to call something called create anchor on it. So that's going to give you a data structure that's going to be kept updated as long as the system is tracking, and that's going to tell you where in space the user has pressed, but it's also going to tell it to you later on down the line. So that means that the 3D, this is all kept up to date by the ARCore system. Right. So what you want to pay attention to right here is the pose. So if you're not familiar with 3D, a pose is basically a description in space where an object is, but it's also an orientation. Right. So I want you to keep that in mind as we go forward. Cool. All right. So we now have an anchor, place to anchor our renderables too. But renderables are something that belong to the Sceneform library, whereas anchors actually belong to the ARCore library. So you might be wondering, what's the difference? Sceneform came much later, and Sceneform is a scene graph library, and ARCore is basically an offshoot of, if you're familiar with it, Project Tango. So it's more low-level constructs. What's fun about Sceneform is, like you saw AR Fragment, it gives you a lot of facilities to not have to deal too much with sessions and all the sort of management you would have had to deal with if you were writing a pure ARCore app. So at the end of the day, renderables can't be directly attached to an anchor because anchors belong to ARCore. So since renderables live in a scene graph, you have to attach it to something called a node. So nodes, right there, right? So a node is the construct that Sceneform understands. And by using something called the anchor node right here, you can take the anchor that you're getting from the hit result, anchor it to a node that can then itself be attached to the Sceneform graph, right? Those are core essentials, and they're kind of hard to keep track of at first, I have to admit. But once you got that down, you'll be feeling very much at ease with ARCore. All right, so if you look at here, this is how you create your anchor node by passing it the anchor. Right, so fairly straightforward, one-step operation. Once you're done with that, you look at taking your node and setting a parent for it. Right now, your node was just floating into space. It wasn't attached to anything. So the root of the graph in Sceneform is how you can see here. It's under AR fragment. You have an AR scene view. And the actual root of the whole graph is this thing right here, scene. Right? So that's also one that you want to remember. Anytime you want to attach something at the root of the scene, and which is where basically everything starts off of, you look for this object. Cool. So let me just look at my notes here. Where are we? Right. So now that we have all this, we could assign our renderable straight to the anchor node, straight to the anchor point. But what would be kind of boring with that is that Andy would basically be frozen in place. He'd just be looking in a direction. It would happen to be the direction towards you where you were looking at when you actually tapped on the surface of the screen. Wouldn't it be much better if you could actually select Andy, rotate him, move him about the table, perhaps even pinch the size and zoom him? So there's an easy way of achieving that, and that's through a type of node that's called the transformable node right there. So by using the transformable node, in which case you pass it something called a transformation system, don't need to worry too much about that. All you need to know is that it's part of the constructor parameters. Once you've done this, that node has all the systems needed automatically to basically get selected when you tap on it. It's going to be able to resize, and you're going to get all those interactions I talked about for free. So now we have our new node, an actual transformable one, a pretty good one. We need to hook it up to the graph, like as I was mentioning earlier. So we use the anchor node we just built. We assign the renderable, as you can see in the code right there. And then we close off by selecting the transformable node. That's just a nice little UX thing for the users. When they're going to tap down, the little figurine is going to be hooked up right away and selected right away. It's really hard to see on the screen, but there's a little gray ring under Andy right there, and that indicates that that specific one is the one that's selected. So for transformable nodes, the other thing to know is you can't select multiple ones at the same time. There's always going to be one selected, and the other ones are going to deactivate, depending on which one you picked. All right. So, and yeah, that's the call right there. So, last but not least, we need to assign that tap listener to our AR fragment, and then we're good. Okay, so then we can start adding little guys in there. We tap, we add more and more, have fun. We can lay them out exactly as we want to. So as far as our pop-up shop goes, this is actually a pretty good base, right? We want to pretend that we have merchandise on the table. We can put it down. We can place it wherever we want. That's kind of cool, right? Right, why not? Okay, but if we intend to sell these things, at some point we're going to have to think about price tags, right? We're going to add some sort of price there. So that's when view renderables come in right there. So you might be guessing by looking at it, but these little price tags are actually Android views. So with view renderable, you take your garden variety XML view, and you can throw it in 3D space, throw it into 3D space. So this works a lot like the views you're used to. You're going to get all the usual facilities, but there's a few key differences, not that many though. The one big one is that view renderables also need to be loaded asynchronously. That's a bit of a pain, to be honest. But once you have them loaded, you can access the underlying views just by calling find view by ID like you're used to. Small difference here, as you can see, is that you take your view renderable and you get your view reference from that. Then you can call your find view by ID. That allows us here to set the price, right? But if you see this, you might be thinking, wait a minute, there might be a bit of a problem here, right? How many of these labels do we have on the screen right there? Yeah, they're all different instances, right? You can't share them across the whole board. You can, if you want, show multiple copies of the same view, but obviously if you set the price on one, all the other ones are going to change too. So in this case, what kind of becomes a bit problematic is that you're going to have to load one view synchronously for each of the little figurines that you're going to put on the table. You could share the copies of the figurines themselves. You could only use one node and replicate it in a few different places. And even the sizing and all of that is not going to affect the core renderable. It's going to affect the node itself. But as far as the labels go, you need different copies of them. All right, so how do we do that? Well, it's not too hard, and that's one of the reasons ArcsJava is kind of useful here. If you want to load more than one renderable, views or otherwise, you can just zip them together. And when the whole process is done, that's where you're going to start thinking about registering a listener. So it allows you to sort of stop thinking about the parallelism of the whole thing and just run things in order. So if ever you start playing around with ARCore, either be familiar with future completables, some ArcsJava or coroutine type thing. That's very useful to sort of get out of trouble, if you will. All right. So once you have all the necessary rendables on hand, it's time to add them to the scene graph, and this is the code that does this. So you might be getting familiar with this kind of operation, and it comes back a lot. You basically get yourself an anchor somehow. We're still on the hit result right here. You put that into an anchor node, right? Again, that makes the bridge between ARCore and Sceneform. And once you've established that bridge, you take your renderable, you assign it to a new node, which is going to go onto the anchor node. We usually do this to just keep it more flexible. If the anchor node keeps moving and is set at a hard position by the system, If you want to put something a bit further away from that anchor node, it needs to be independent from it. So you can attach a node to another one as a child. So when the first one moves, the second one's going to move relative to it. If you would assign the figure to the actual anchor node itself and say move it 50 centimeters this way, whenever the system would update the anchor node, it would just bring it back here, right? So that's why it's important to actually create these different little links. Okay, so how do we configure the price node tag? This is how it goes. You don't want shadows. So the idea is that for some of these UI elements, if shadows are there and you have a few, it starts to look kind of weird. You want your view to be a maximum of 10 centimeters wide. So this one's kind of interesting. It's sort of in this case, we give it a maximum width, right? 0.1 here, this is in meters. If you want, though, you can also give the renderable system a comparison measure between dPs and meters. So if you have a view in ARCore, you could decide to hard code all the values just to make it a certain size. And by declaring how many dPs is how many meters, you're going to have like steady, real life-sized views, if you see what I mean. Renderable assignment again. So in this talk, in 3D talks in the past, I tend to spend a lot of time on math and how to rotate stuff. I'm not going to do that here. And the good news, though, is that it's relatively simple. Like all working with quaternions usually is like worth like a good half hour on itself. But here we have nice little methods that allow us to just basically specify a rotation vector and just apply degrees to it. So that's pretty cool. We don't need to think about it too hard. And this is just like 3D positions in real time, in real space, sorry. So right here, we want our price tag to be a little bit in front of our Andy figure and also a little bit above the ground, right? So we're talking 2 centimeters above and 20 centimeters in front of. Last but not least, we need to add this and attach it to our graph. And if you remember, right, the Andy node in this case is where we want to go because we also want to be relative to the figurines, right? So at this point, we have anchor node, model, price tag. And this is the kind of stuff that you're going to want to build in ARCore a lot. In Scene Graph. Right, we have our price tag. It would make sense to offer some other type of UX, right, to actually purchase our minifigs. So this is another type of UX. At this point, it gets a little bit more interesting, mostly because I just wanted to show the set on click listener. This works exactly as you'd think. And here I only have a static screen. I don't have the animation, but pressing on the buttons acts like you would expect. The button goes down, it goes up. All the standard styling you're used to in your UIs is totally applicable here. So that's a really powerful feature if you want to make less of a toy app and more of something that actually has a UI that users interact with. Yeah, so find by ID. I keep forgetting I put all these animations in there. Why did I give myself that trouble? All right, so different feature of ARCore. We're going to jump to slightly different things. ARCore has a capability to recognize pre-programmed images in a given environment. So what does that mean? You take images that are good candidates for recognition. So there's a command line tool right here that allows you to evaluate pictures like these and gives you a score. So if you see at the very top, I ran this ARCore image eval program, right? And the score for both images is 100%. So that means that both of these images are really good for ARCore's recognition system. If your own images are not up to snuff, you're going to see ratings down there sort of start dropping steadily. If ever you see something under the 90% score, I'd consider finding a different image. A few hints on that: if your image is too regular, it's like a checkboard pattern or something like that, the score is going to drop dramatically. Pictures like these that have like very uneven features in there are usually the good ones to pick. There's a few more commands in there on how to create those image databases. They're not that interesting, to be honest, but the key thing to understand is that you take a list of images, you create a list of them in a text file, you pass it to the command line tool, and it's going to generate for you an image DB. And that image DB, we're going to see how to load that into our app. Oh yeah, first though, how do you use that in the emulator? Another feature in the camera emulator, you might have seen it and wondered what the heck is this for. It's actually to anchor some of your own images into the room that we just moved into the virtual space right there. So that's a really nice place to test the augmented image detection system. Cool. So this is how you configure your image database in an ARCore session. It's the first time I've actually mentioned that you can extend AR fragment, and you're encouraged to whenever you want to start tweaking the session or how things work. Here we're doing something pretty straightforward, right? We're just going to be loading the augmented image database. But using this extension technique, you can change configuration parameters for all sorts of things in ARCore. Given the time, I knew I was be short on time, so I don't cover any of that here. You can look that up in the documentation. All right, cool. Setting up a listener to get updates on augmented image tracking, that's a bit involved. The core idea is that if the ARCore camera is tracking in a tracking state, if you remember earlier we talked about tracking, stopped, or paused. So when things are tracking, that's the time that you want to ask ARCore, okay, right now in this frame I'm tracking, how many augmented images do we know about? And by using this code, the get updated trackables call, you pass in the type of trackable that you want to track, and it's going to give you the full list of whatever is available right now. So that's how augmented images are accessible to you. Using this, what we can do is start assigning our anchors to the augmented image. So again, it's the same thing. The augmented image gives you an anchor that you can use to hook up into your graph. Same kind of calls. Small difference here is that we put a different AI, we just use different measures here. So we put this AI for the whole store at the top of the segment. So that's something that's more of a permanent fixture, and that's what augmented images are usually good for. Right? So if you want to put a virtual environment that doesn't move and is a fixed place, so if you put this picture in your own environments, you're going to end up with the UI always being in a predictable spot. Cool. All right. So, wow, I actually have a blank slide in there. That's interesting. Cool. So we've added a lot of affordances to our store. It's covered a lot of the material that should help you get started writing your own ARCore apps. I think you have most of the pieces needed right now to just write your own. As you can see, there's nothing extremely magical in there. You don't need to have a degree in OpenGL or something to get this to work. It's pretty straightforward. We do have a big problem with this app. Maybe you sort of see the hint of it. This is kind of bland, right? If we want to store, I don't know if we can have only one type of merchandise. So we need to diversify if we ever hope to make a sale at some point one day. So how do we do that? Right. Nothing too fancy today. Customizing materials is also an hour-long talk of its own. I found out pretty late in the game, to be honest. I thought we would be talking about this a lot more. But today I'm going to show you how to open that door and start digging into that rabbit hole. So the main place where you start doing this is with declaring your model building right here. So if you remember at the beginning of the talk, we had this line here that was default, right? So if you want your custom material, what you need to do is to define your own file and replace default by this right here. So when you do that, the Sceneform plugin is going to generate a different type of SFA file that will refer to this custom material. And then you can start going into the custom material file and writing your own rules. So what does that look like? So your SFA file will start looking like this. So what you can see is that at the top section here, we have a source custom material right there, right? So that's our first gateway to setting up our own materials. So jumping in, we're going to have, so the first thing to look at is the following. So the way that I've set up this particular scene, you see how all the Android figurines are different colors. This is only one model. So what we have here with custom materials is that it's possible to declare parameters that you will programmatically set in your app to affect how the materials are going to render afterwards. So as you can guess, that's a pretty powerful feature, and you can start, so you might be wondering how much can you actually customize when you start doing this kind of stuff. So who's familiar with GPU programming and shaders in the room? Like one or two people. So if you've ever played around with graphics, it's possible to write small scripts to program your graphic cards or your GPUs on your phones to get them to render very interesting things. So the way 3D works, you generally write this code in something called a fragment shader. So ARCore gives you a chance to customize your own shaders, and it's a fully fledged language of its own. Up there encircled in orange is how you pass parameters into that fragment shader. So the way fragment shaders work, their job is basically very simple. They get a few parameters, something like X position, Y position, and a few other things about light and the surface they're trying to paint. And their job is basically to take one pixel and assign it a color. So the code that's in there is basically all concerned about calculating where light is coming from, what type of surface is represented by that pixel, and making a fancy little calculation that will just bring back a pixel colored the right color. So this example right here is a very simple one where we changed the properties of the material to become super metallic with a roughness of 0.5. So that's why these things look a little bit like aluminum instead of shiny chrome Andy figurines. Cool. So, yeah. So in the code, when you want to configure the parameter, this is what it looks like. It's fairly straightforward. So you take your renderable, which in this case is custom Andy. You say, I want to get the material, and then you pass in whatever parameter you've defined in your custom material. And here's a vector of 3 floats, so that's basically 3 floats representing a color, RGB, as you're probably familiar with already. And once you do that, you can assign whatever color you want to the shiny little, let's say, aluminum Android guys right there. Cool. So that's about it for today. I do have, in closing, some takeaways to share with all of you, which might be useful in your own explorations. So as you might guess, they're not so easy. Using scene graph is mostly tricky because of the asynchronous nature of loading assets. So if you cover that base with your day-to-day knowledge from your day job, not playing around with toys, basically, then you'll be in good shape. As long as you have a good library to sort of load your resources asynchronously and tie everything together, things are good. Removing and adding some UI and responses to selections with the scene graph is also kind of tricky. You need to think about scope, and you also need to think about the fact that a scene graph is the most stateful of stateful things you've ever worked with. So if anybody's a fan of functional programming in the room, this is not where we're at. You might be wondering why, and I think it makes good sense in the graphic world because you want to optimize the hell out of everything. So typically, that also means not allocating a whole lot of object in a hot loop. So that's usually, I think, the reason why things are that way. The level of support for standard 3D formats is really awesome. We saw how we could customize materials even for some old 90s OBJ standard right there. But if you start playing around with GLTF files and the different tooling that's available to actually bake textures and make really impressive things, you're going to see that it's really easy to connect that with ARCore and Sceneform specifically. Other things you can actually do that I didn't talk about, it's possible to split the feed from the camera. So you can take the pictures from the camera, have ARCore still engaged in doing all the fancy 3D stuff, but you can pass that stream as well to OpenCV if you want to, or your own ML language stuff. So all of this can work. Other really good thing, which I hoped to cover today, but sadly I couldn't, lack of time, cloud anchors. So cloud anchors would allow us to create a pop-up shop that anybody in the room could open their phone, actually look at the same shop, and we could interact live on the same virtual affordance. So that'd be pretty interesting as well. And all in all, I think it's a really awesome library to explore. I hope today I managed to encourage you to do your own explorations. Really a pleasure to have the privilege of talking at Android Makers. So thank you very much and hope to see you later. There might be some really, really messy code at this GitHub address at some point later today. Thanks. If there's any questions, I think we have, do we have time or we're done? I think we have only 2, well, okay. So if there's any questions, first. Sorry, could you repeat that? Animating models. So there is a framework for animating stuff. I have not played with it. There's a few samples. They seem a bit rough, but what I've seen is that you can also import standard animation files into the system. I don't know how good it is, to be honest. I haven't played around with it. You could get longitude and latitude. So yeah, I'll repeat the question. So what about working with, well, geoposition basically, right? Nothing stops you from using your standard location services and then maybe from there trying to hook up people to the same space. Of course, ARCore is more an indoor thing and location services are not usually always that great. But if you're looking to do something like Pokemon Go, there could be some interesting things there for sure. Any other questions? I think somebody else had a question. Yeah?
So related to that, how about rendering relating to your current position? So not outside, but you're in a room.
Right.
You want to put things around you at a certain position.
Right. So there's ways.
They remove.
Yeah. Right. So there's ways of doing a lot of that. So yeah, there's a few caveats. Like if anybody's seen some of my past talks, I have like a little experiment where I have a little robot where I put an augmented image on the side and I use that to actually try to remote control the robot with an ARCore app. That kind of works. The problems with that approach though is that augmented images are it's usually expected that they're going to be pretty big. So the use case is that we're talking about a poster 1 meter by 1 meter that's on a wall somewhere. So those are cool if you want to sort of locate yourself in a room, but if you have moving parts in a room, not so great. Like I managed to get the robot to do some tracking on the floor and stuff like that. But to be honest, if that's your goal, you're probably better off using OpenCV or one of those other libraries to sort of locate things in a room. But as far as like fixing 3D virtual stuff in a room with like a big poster and things like that, ARCore is pretty good with that. Yeah.
Thanks.
Yeah, pleasure. All right, we're done on time. So thanks again, everybody. What?